All right, so let's try number 7. Roll 2 dice and observe the sun. You have a beautiful sample space for that from number 1. Define the events as follows. All right, your value is even, value is odd, value is less than 6, and value is greater than or equal to 6. Write the sample space for the observed sun. All right, we gotta do it again. I'm gonna do it so I can color it. So heads up, guys, the way this works, stuff on the outside is just for organization. The actual sample space goes in here. So I have a 1. Not the best use of time, guys, sorry. But I'm gonna be coloring this, so hopefully that'll be helpful. So die number 1, 1, 2, 3, 4, 5, 6 happens. I would make a really thick line out here because it's not part of the sample space. And number 2, 1, 2, 3, 4, 5, 6 happens. Okay. So, and then the instructions here are when you do this, you roll your 2 dice and you add the sum. Now, heads up, if you haven't seen this before, super important, you want to know this pattern. Along the diagonals, you have the things that are the same. As you go, there's more different ways to achieve the things that you want. So there's only one way to get a 2 when you roll 2 dice on 1, but there's 5 ways to get a 6. You can get a 1 and a 5, you can get a 2 and a 4, you can get a 3 and a 3, you can get a 4 on the first die, or 2 on the second one, which is different than this one. So just make yourself very, very at home with this. You want to really understand this diagram. So 7 is the most common outcome because it's got the most options. Okay, so I'm doing this because I'm going to color coding these events on here. So there's my sample space. Write the probability distribution for the sum. Okay, so this one is going to be take these guys and turn them into how likely each of these is. So what's the sum you got and what's the chance of getting it? So this one, cross fingers, probably won't fit, guys. Oh, hell no. 2, 3, 4, 5, 6, 7. Gotta squeeze. 8, 9, 10, 11, 12. And then how likely each one is. There's one way out of 36 options. So sample space, 36 outcomes. Right? There's 36 boxes, 6 times 6. 2 ways to get a 3. 3 ways to get a 4. 4 ways to get a 5. 5 ways out of 36 to get a 6. The most common one, 7. And then this is super symmetrical. It's going to come back down. So 8 has 5 different ways. 1, 2, 3, 4, 5. Out of 36. 4 out of 36. 3 out of 36. 2 out of 36. And finally, only one way to get a 12. So this is B. So this is A. Are the events A and C mutually exclusive? Disjoint. Are they both possible at the same time? Okay. So you can do this numerically, you can do this visually in the sample space. So A is even. So I'm going to color code any outcome that is even. If they're mutually exclusive, the idea is there's no overlap. They cannot both happen at the same time. So what's going to happen is I'm going to shade these. And if I shade these orange, event A is orange, and event C will be whatever color I pick next. If there's anything that gets both colors, they're not mutually exclusive because they could both happen at the same time. All right. So mutually exclusive means no overlap possible. Cannot have both happen at the same time. So if event A is orange and event C is green, can I make both happen on any of these boxes? Event C is value is less than 6, so 6 doesn't count, but 5 does. So that's not double overlap, but, oh, 4 is also less than 6. These guys are about to get orange and green. So look, overlap is possible. We can do both at the same time. That means they're not mutually exclusive. So we're going to say because the 3s and the 5s got both colors, overlap is possible. And the conclusion is not mutually exclusive events. All right. D, are they independent? All right. So these are two really common questions, these two ideas. So these are ways that two events can interact that are special. Most of the times they're not either this one or that one. So mutually exclusive, can these two events overlap? The answer is yes, they're not mutually exclusive. And the second one is independence, which unfortunately is not a visual thing. Independent. So is the chance of being even independent unrelated to no effect on the chance of being less than 6? So there's two ways to do independence numerically. You do it conceptually as well. So is being even unaffected by being less than 6? There's a couple ways to do this. I'm going to show you both methods. Method number 1 is to think about the event, the probability of A given C, or you can do it the other way around. So this will be the chance of even given that it's less than 6. Is this the same as telling me something is even where being less than 6 does not affect it? So this is one way to check for independence. So let's talk about the probability of A given C. The chance of something is less than 6 is we shaded 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 things green. That's the chance that was A. A was orange. 1, 2, 3, 4. So that's the chance of A given C. That's the chance of being even given that it's less than 6. The chance of A of being even is, I believe, half of the boxes. So it's going to be 18 out of 36. So the question is, are these two equal? Not equal. And that means not independent. So that's one way to do it. The other method for checking independence numerically is that the chance of A and B overlapping should be the chance of A times the chance of B if they're independent. So the chance of A and B happening, got both colors, was these guys and these guys, right? So there were 4 events out of 36 that were both less than 6 and even. The chance of being even is 18 out of 36. And the chance of being less than 6 is everything that got green, which I think we decided was 10. So this question is asking, is this numerically the same? I think the answer is no. Right? I would just provide these numerically. So we have 4 out of 36, which is a really cool number as a decimal. 0.1111 repeated. Is this the same as a half of 10 out of 36 into 2777? And the answer is going to be, no. This is 0.1388. So not the same, therefore not independent. So knowing that something is less than 6 affects this chance of being even. That's what we found out. Therefore not independent. All right, E. Find the union of A and C. So find all of the events that are either even or less than 6. So I'm just going to refer you to usually anything that got shaded is the union. Right? So we're going to say anything shaded in the chart is A union C. So either even or less than 6. And I'm not going to list it out. It's pretty long. Calculate the probability of A union C. So this is a number. This is a bunch of events. This we can do. I think the easiest way is to look at anything that didn't get shaded, right? All these guys are shaded, and we have the 7s, the 9s, and the 11s are not shaded. So I'm going to use a really important concept here, which is that the things we want and the things we don't want add up to 1. So I'm going to do 1 minus. I'm going to color just count the things that have no color. So there's 6 7s, 4 9s, so that's 10, 12. So that's going to give me a 36 over 36 minus 12 over 36, which is 24 out of 36. And then heads up, guys, I do not want you to simplify your fractions. I actually don't want you to simplify your fractions. There are 36 outcomes, and 24 of them are things we like. I need it that way. Now, we haven't looked at the other two ideas. Find B union D. So anything that is odd, or I'm happy if it's odd. I'm also happy if it's 6 or more. So I would list out all 18 odd numbers. Right, so we're going 3, 3, 5, 5, 5, 5, 7, 7, 7, 7, 7, number 7, 9, 9, 9, 9, 11, 11. And then I need to add everything that's 6 and above. So all the 6s. So anything that's above 6 that wasn't odd that I haven't mentioned yet. So I need 5 8s. I wish I had made another one to shade. All 3 10s. And finally the 12. So all of those, and calculate the probability of this. I think it's probably the same as the other one. I just count how many I have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. That's a lot more than the other one. Okay. So probability of B union D is 32 out of 36, which means the only thing we missed or skipped were, even numbers below 6. So 4, 4, 4, and 2. It's the only things we skipped.